In this video, you will be learning about how to simplify a radical. That is your one and only objective during this lesson. Simplifying a radical has to do with perfect squares, and most of the perfect squares you've learned about before. You may even have the first 15 memorized, which will help you tremendously. If you don't, though, we'll go over that in a little bit later. First, let's talk about what is a radical. A radical refers to the root of the number. And in the Pythagorean theorem unit, this current unit, we're going to be talking about square roots specifically. Now, in order to simplify a radical, we need to figure out what kinds of perfect squares go into the number underneath the radical. So, a perfect square is any integer squared. And the first 15 are 1 squared, 2 squared, 3 squared, 4 squared. Keep squaring each integer up to 15, and we'll write down the actual numbers underneath. So write all the way up to 15. And like I said before, you might have some of these memorized, but you might not. The first few should be easily memorized. 1 squared is 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 13 squared is 169, 14 squared is 196, and 15 squared is 225. So what you are going to do is find the largest perfect square for each number underneath the radical. So find the largest perfect square factor in each radical to simplify. So 12, the square root of 12 is given for the first example. 12 is not on this list. It goes 1, 4, 9, 16. Not a perfect square. But is there a perfect square that goes into 12? Look at your list. The biggest one would be 4. 4 goes into 12 3 times. So I'm allowed to rewrite this as the square root of 4 times 3. 4 times 3 is 12. So I'm allowed to split up 12 into 4 times 3. Now why did I choose 4? Again, because 4 is a perfect square. And the square root of 4 gives you an integer. The square root of 4 is 2. So I can rewrite this as 2 times the square root of 3. If I were to square root 4, I get 2. So this turns into this. The square root 3 does not change because 3 is not a perfect square. And we want to keep these numbers exact. There are no more perfect squares that go into 3, so you are finished with this problem. Let's go on to the second example, 72. Is there a perfect square that goes into 72? Okay, 4 is definitely going to go into 72, but is it the largest one? It is not. It turns out that 36 goes into 72 twice. So I can rewrite this as 36 times 2. Now if you're wondering where I got those numbers from so quickly, number 1, I've been doing it way longer than you. But number 2, if you wanted to work backwards, if my number is 72, that fits in right about there in the list. So work backwards from there. So do 72 divided by 64. If you get a whole number, that's your perfect square. If you don't, move it along. So 64 doesn't work, 49 doesn't work, 36 ends up working. It's 36 times 2. So you rewrite it as square root of 36 times 2. And this is good for you because the square root of 36 is 6. And times root 2. 2 is not a perfect square, therefore it's going to stay inside the radical. And you are finished. Let's do another example. Number 3. the square root of 48. You need to find the largest perfect square that goes into 48. So starting at 48, 49 is too big, 36 does not go into 48, 25 does not go into 48, 16 does go into 48. See how I'm working backwards from the number where it fits in the number line? So it goes into 48 3 times. So when we write this as square root of 16 times 3. The square root of 16 is 4, and then root 3. Root 3, the square root of 3, is not a whole number, therefore you leave it as 4 root 3. Let's do one more in this first row here. Number 4, the square root is 75. Working backwards, 64 does not go into 75, 49 does not, 36 does not, 25 does. 25 goes into 75 3 times. So it's the square root of 25 times 3. Square root of 25 is 5. And rewrite the square root of 3. And that is your simplified radical. Now, 3 of these examples have the square root of 3. Again, it's not always going to be square root 3. Obviously, it could be square root 2, it could be square root 5 as well, depending on the problem. Let's do a couple more in this bottom row. 600, okay, it's larger than any of the numbers that I listed. However, 600 should be pretty easy. 100 goes into 600. 6 times. And 100 is a perfect square. The square root of 100 is 10. Root 6. 6 is not a perfect square, therefore it does not leave the square root. Sorry, I had some issues with the keyboard. Let's do number 6, 320. There's lots of perfect squares that go into 320. 4, 16 does. But the largest one is actually 64. So we're just working down the list. The large one's going to be 64. And 64 goes into it 5 times. The square root of 64 is 8, so that can come outside of the radical. 5 has to stay inside because 5 is not a perfect square. And you are finished. So to recap, the objective was to simplify radicals, and we simplify radicals by finding the largest perfect square that goes into the number underneath the radical. So if you don't have them memorized, they are listed here. You can rewrite them in any other practice you need, or you can reference this page. It will not matter. If you are unsure of what perfect square goes into the number, simply work backwards on the list with your calculator to see which one gives you the whole number factor and use that to simplify.